Here we have a strain gauge rosette mounted to an aluminum tube. We're using this apparatus to try to experimentally determine how much mass is being applied on an offset to this tube. So it's applying a torque and a bending moment. So by measuring the state of stress in the bar with the strain gauge readings, we can predict or compare to the theoretical stress values to determine how much mass is being applied. Here we have a commercially available strain gauge bridge, which allows us to take measurements from the strain gauge. It converts the resistance changes, the small resistance changes in the gauges, to voltage readings. This is a rectangular strain gauge rosette, and it contains 3 gauges oriented 45 degrees apart. You can see the connections to each of the 3 gauges.
Before we apply a load, we have to balance the gauge in the unstrained state. To do this, we adjust the potentiometer to balance the bridge. We try to get these 2 lamps to dim out, and we can also look at its voltage when the voltage goes to 0. So you can see it's getting smaller. When the load is applied, the voltage will change in proportion to the weight applied. From this voltage, we can calculate the strain in the strain gauge, and this, along with the other 2 strain gauges, we can calculate the mass hanging from the apparatus.